Hi class. In this video, I'll be working through some examples from your section 9.3 WebAssign. This is adding and subtracting and multiplying radicals. The first question says simplify the expression. The key to adding and subtracting radicals is that the number under the radical must be the same. In this example, we have radical 11 in both terms. When the radical is the same, this is the easy part, you just combine the outside numbers. 9 plus 3 is 12, and then you keep the same radical 11. It really works like a variable, like if you had 9x plus 3x, that would be a total of 12x. It's the same idea as when we add or subtract radicals. Okay, so let's try that again, except this time the numbers underneath the radical are not the same. We have 2 times the square root of 18 plus 12 times the square root of 32. The first thing I want you to do is, since we don't have the same number under the radical, is to simplify each radical and rewrite them in its most simplest form. And to do that, make factor trees of both radicals. Okay, here's what the factor trees look like. I broke 18 down to 3 times 3 times 2, and then 32, I broke it down all the way to 2 times 2 times 2 times 2 times 2. Okay, so now we're going to rewrite these original radical expressions. Notice there was already a 2 on the outside of the square root of 18. Now there's a pair of 3's. We'll multiply 1 3 to the original 2 to get 6 square roots of 2. Now looking at the factor tree for 32, there's 2 pairs of 2's. There was already a 12 on the outside. We'll multiply 2 2's, which is a 4, times that 12 to get 48 square roots of 2. Now the problem is 6 square roots of 2 plus 48 square roots of 2, which is a total of 54 square roots of 2 as a final answer. Okay, so let's try that again. We have the square root of 112a to the 5th minus 2a squared times the square root of 63a. The first thing I want to do is draw out the factor trees. Okay, so I went ahead and did the factor trees. If for some reason you're working through your homework and you're stuck on a particular number, so for example 112 is not a common multiplication answer, I'm okay with you to use your calculator if you're in a pinch like that. But 112 is 7 times 16, and then I broke it all the way down to 7 times 2 times 2 times 2 times 2, and then I wrote out the 5 a's. 63a simplified. When I made the factor tree, it broke down to 7 times 3 times 3 times a. Now we'll rewrite both of these radicals by identifying pairs of numbers. There's 2 pairs of 2's and 2 pairs of a's. There was not a number outside the original radical, and so to rewrite this first radical would be 4a squared square roots of 7a. For the next term, there was a negative 2a squared, and we'll be multiplying by a single 3. So negative 2a squared times 3 is negative 6a squared times the square root of 7a. Now that the radicals are the same, we'll just subtract those outside numbers to get negative 2a squared times the square root of 7a. Okay, now we're going to multiply and simplify, which I think you'll find this to be pretty easy. You can multiply this to be the square root of 150 and then simplify 150 by making a factor tree, or it's also the same if you just write one large radical and just write that multiplication 10 times 15, right? Because 10 times 15 is 150. When you make a factor tree of 150, you're going to break it back down to 15 times 10. And so you can actually save a step and not multiply and just combine the two terms under one radical. Now we can simplify 10 to 2 times 5. Simplify 15 to 3 times 5, and we have a pair of 5's. If we simplify this expression, square root of 10 times the square root of 15, we'll have a 5 outside the radical, and 2 times 3 is 6, and that remains inside the radical, and that's your final answer. Okay, let's try that again, except we're going to multiply using the distributive property. Square root of 7 times the square root of 42. Again, I'm going to encourage you not to do that multiplication. Just write 7 times the square root of 42, and then square root of 7 times 2. Whole numbers always go first when you're writing a radical, so put the whole number 2 and then square root of 7. Now for the simplifying part, the first radical can be simplified to 7 times 6 times 7, and then we can simplify 6 to 2 times 3. There is a pair of 7's, And so that first radical simplifies to 7 square roots of 6. The second radical, you cannot simplify the square root of 7, so it's going to remain the same. And take a look at these radicals. They're not the same radicals, and so you cannot add them together. So your final answer will just be a binomial of 7 times the square root of 6 plus 2 times the square root of 7. Okay, I'm going to multiply again. This example, we will multiply and simplify, but we'll follow the FOIL method. Remember, FOIL is first times outer, and then multiply the inners and last. So 7 times 7 is 49. 7 times the whole number 8 is 8 square roots of 7. Negative 1 times the square root of 7 is negative 1 square roots of 7. And then negative 1 times 8 is negative 8. Now we'll simplify. We know the square root of 49 is 7. We can also combine those second and third terms because the radicals are the same. That can be combined to 7 square roots of 7. And this negative 8, I'll go ahead and write it one more time, but do you see how the first 7 can be combined with the negative 8 to give us a final answer of 7 square roots of 7 minus 1. Okay, and that's all for this video. Please let me know if you have any questions on this homework assignment.